Okay, so let's move ahead. Mm, In last class, we had discussed about the one-step Arduino bond estimator. Today, we will do two-step Arduino bond estimator with and without additional regressor. And after then, we do two diagnosis tests. The one is called the test for autocorrelation, and the another one is test for over identification of instrument variable. So that also called the over identification test that we did in when we are doing instrument variable regression model. So let's start with the two-step Arduino bond. So for a one step, as we know, last time we have used command xt a bond, that means xt Arduino bond. Then after dependent variable, which one is in our case log of which. Then we have a specified option lag 2. Lag 2 means we are using two lags of dependent variable as a regressor. Which one is first leg of log of wage and second leg of log of wage. And then after VC robust command just to get rid of autocorrelation problem. Otherwise, we get inconsistent estimates of parameter. So so this one is the result in case of one estimate. Last time we had interpreted the regression result. So mainly last time we had some confusion in interpreting lag value of log wage coefficients values. So the interpretations goes as like, since explanatory variable are here in lag terms, lag 1 and lag 2, that means in wage at period 1 having a impact on wage at period 2. Similarly, wage of period 2 having I sorry yeah wage of period 1 having a impact on wage on period 3. So because lag of wage, the first lag of wage is having an impact on current year of age. Similarly, second lag and previous 2 years value of wage affecting current value of wage. So we can say uh, that if there is a rise in 1% wage level in period 1, so because of and if there is a rise in wage of 1% in period 1, that affects the wage of period 2 by 0.57%. Similarly, the rise in period 1 affect the wage of period 3 by 2.26%. Since I'm using percent because both the dependent and independent variable are here in log term. So the impact of current period wage impacting the future period wage rate. So so given the case there is a rise in 1% wage at a current period, that is going to be affect the wage earned by individual in a future period. So since you have included here only 2 lakh value of wage, so the first lakh value of wage having an impact on current value of wage by 0.57%, and the second year lag value of wage having an impact on current value of age 0.26%. Cumulative impact of lag value of wage of period 1 and 2 on current period is 0.84%. And you can see here the coefficient value of both of these coefficients are statistically significant. The about the number of instruments we have already explained. So if you read the bottom lines where it say GMM type L bracket 2 hyphen dot, that means this regression model have used instruments starting with the yt minus 2 and so on. So yt minus 2, yt minus 3, yt minus 4, yt minus 5 and so on. So since you are having only 7 year of period, and after truncating the data, because 3 year period has been elapsed, so we left with the 4 period of data. At max, there would be 4 lakh value of instruments for 1 year, and that you have seen. And how we construct an instrument, for that we'll take a help of this particular slides. So for period 4, from which our data set is starting, of course, after for 5, 3 instrument, for 6, 4 instrument, and for 7, 5 instrument. So the total instrument become 14, and one is intercept. So total instrument is 15. And this one is important to understand. Once you understand this one, then there would be no problem of understanding anything. So now you are having a 15 instrument. Okay. Okay. So at most you are having a 5 instrument lagged instrument of, or you can say 5 instruments of lag value of yt. So yt minus 2, yt minus 3, yt minus 4, and yt minus 5 for 7 period of data. You can say something like that. Of course, for each year you are having a different number of instruments. For t equal to 4, you are having only 2 instruments, and for t equal to 5, that means for 4th year or for 5th year you are having a 3 instrument. For 6th year you are having a 4 instrument, and for 5th year you are having a 5 instruments. Total you are having a 15 instruments. Now let's move on to the 2 GVM estimator. So in a 2-step GVM is sorry, 2 steps early bond estimator case, we just need to type here 2 step as a option while estimating the regression result. So if I enter, we get this estimate. So again, the instruments are 15. Method is a bit different. Earlier it was 1 estimate, now it is 2 estimates. Now we can uh, compare the difference that we are getting from 1 step and 2 step. So if you have a look on the coefficient value, so now you are having a coefficient value 0.60 and 0.27. Again, both of these are statistically significant. And comparing with the previous estimates, in a previous estimate, we have gotten 0.57 and 0.26 as a estimates of log of wage at different lag period. So it is uh, almost same. You can say this one is 0.57, 0.60. Now compare the standard error. So in the first estimate, we are getting a robust standard error, and the second one we are getting a uh, end measure standard error. So that's called the WC robust standard error. And if you compare the standard error, so again we are getting a almost same standard error. So when measure is for a for a first leg of which it is almost same, slightly lower, and for second leg period it is a bit higher. Earlier it was 0.024, now we are having a 0.027. But we can say that only it is almost same, or we can say there is a slight increment in standard error in a case of two estimate two step early bond estimator. Theories say that the more efficient we get in case of the more efficient estimator we get in case of two estimator, and because of that reason we are using two step early bond estimator. Again, it is said that if you use textbook standard error instead of wind measure robust standard error, in that case we will get a underestimation of standard error. So wind measure standard error one is more of uh, appropriate standard error as compared to the textbook standard error. It is standard error. Textbook I'm saying the standard textbook uh, standard error, and uh, both of these standard error do not have autocorrelation problem, but you might get a heteroscedasticity problem in both of these two regression error regression model. Now, since you have used a 15 instrument in both of these regression model, so there is an option to restrict number of instruments, because
Sir,
if you use a larger number of, yes,
sir, which one is the two-step one?
second one is later one is two step written here two step
So what do we do in this?
in which pardon,
Sir, am I audible?
yeah, you are.
Sir, I'm asking what do we do in the two-step one, in the two-step estimator?
You know, as much I know, in a two step you use and a two step estimator use a reduce estimated from one step estimator. How this and how it is used, that I do not know. Probably for that we have to go back onto the theory, and or you can say the methodological aspect is how the two steps GMM is calculated.
Okay, sir.
Okay, so but and it, as far I know or I read from the book, the two-step estimator uh, gives a more efficient standard error as compared to the one step. And even in two step, there is an option to use a standard formula of standard error, which we generally use in case of heteroscedasticity and autocorrelation case. If you use that, uh, then we get probably we get an underestimation of standard error. And that generally happen. That one is the, I mean, the standard drawback of uh, any autocorrelation problem. When regression models suffer with the autocorrelation problem, generally get an underestimation of standard error. But since this particular model, both of the two models, one step and two steps, are not suffering with the autocorrelation problem. But even then, it's like if you use the standard formula of standard error, then you will get an underestimation. And to remove that, a textbook suggests us to use wind measure standard error. And that's why Stata report wind measure standard error along with the result. So that's the case. Now let's move on to the further. Since you are using a here 15 instruments, so since now we are dealing with the only 7 period of data and with using two lagged value of dependent variable, the instrument variable without any regression is 15. If you work with the more years of data with different regressors and with more regressor, then we get an larger number of instruments. And using those instruments, okay, undermine the asymptotic result of estimators. So to get rid of that, uh, we restrict Stata to use only certain number of instruments. And how we do that? We put a cap by placing an option H. Let's put here option MAX. That one is they call maximum L dependent. And this one is if we put one, then only one instrument of endogenous variable is considered for one for each period for defining instruments. So let's see that if you run with that, total number of instrument is 5 only. 4 is for 4 time period. So for each time period, we restricted ourselves only for one instrument variable, and the fifth one is intercept. If you restrict ourselves to 2, so maximum L dependent one is 2, that means you are letting Stata to use only 2 instrument variable, up to 2 instrument variable, and use maximum 2 instrument variable for each time period. So if you do that, let's see here, the number of instruments become 9. So 2 for each period, that one is 8, and 1 intercept. Now have a look on the estimated coefficient, value of estimated coefficient. So with the 9 instruments, we are getting estimated coefficient 0.66, 0.22 for different lag. With the one instrument, we are getting 1.848 and 0.37. And when we haven't put any distinction, what we are getting coefficient estimate 0.60 and 0.27. So you see here the sensitivity in the result with respect to using number of instruments. So result get changes when we use different number of instruments. So if you can see here Nino bond estimator, which is based on GMM estimator, is very sensitive with using number of instruments with the model. So
Sir,
yes,
sir, even the standard error is changing.
Yeah, standard. Yes, of course, standard error is also changing. So both the coefficient values and standard error are changing. And uh, and this generally happen when you use lag value of not only dependent variable but also I remember when I were working with the time series data at my MA time. Okay, so you used to get a such kind of result, particularly with the vector autoregression model. I remember. Okay, so the solution of uh, like I mean to say, ki, okay, this one is the particular case where we are using a student variable regression model. Uh, but the solution I'm going to talk about is applied in general, both in case of uh, student variable dynamic panel data regression model and also the standard time series regression model. So in a vector autoregressive case, uh, we need to determine the optimum lag length, and and that we do using Akai information and Swaz information criteria. So you run a different model, record AIC and BIC information, statistics, and at the end we compare which one giving us lower value of AIC and BIC, and whichever gives a lower value, we go with that. Now in this day, uh, there is a command which automatically generate you a optimum lag length of lag length of dependent or independent variable. So that's help a lot, but ultimate the basic theory will be remain same. We use AIC and BIC criteria for determining the optimum lag length. Uh, since here in in this in student variable case, we can see further there is a one particular test which we call the sergeant test, which one is the just a test whether we are using. I mean, so I think that one is just a test whether we are using more instrument variable than required. And if the test reject, then it say that the over identified restriction is not valid, and if test accept, then we can say over identified restriction is valid. So coming on to that, but for time being, for you people, just remember before checking a leg length or optimum leg length, we use AIC and BIC or SIC information criteria. Now let's move on to the next stage in which we use additional regressor in a two-step and bond estimator. So for that, uh, uh, so as a additional regressor, what we are use, we are going to use marital status, MS variable. We are going to use union variable if wage set by a union contract. We are going to use south if residence is in south area, takes the value one, which one is the dummy variable. I think so. SMSA, which is an again seems a dummy variable. I have to check. And IND, which one is related with the industry information if working in a manufacturing industry. We use occupation. These are the variable which has been used in microeconometrics with this data book. So let's use all these variables. I'm typing XTA bond, the earlier command, or let me go with this. So ln wage one is the dependent variable. Along with dependent variable, I am typing here OCC, going to use south, going to use SMSC, then IND. We are restricting ourselves to the two lag value of dependent variable as a regression. So lag 2 option goes as it is. Two step again goes as it is. AC robust we are going to use. You are here you are restricting instruments up to 3. The maximum instruments used by this model is 3 only. Then you are going to define the pre-lagged and predetermined variable. I will come on to this what this predetermined variable is. So the variable name is here WKS, which one is week work. Lag value one is 1 dash 2. I will explain what this mean 1 dash 2. Then endogenous variable again. So apart from lag value of wage, there is one more endogenous variable. That one is MS. MS is marital status. And for this, I am typing lag 0, 2. Then one more endogenous variable is there, which one is union. We type lag 0, 2, bracket close. And then we type here test 3. This one we use when we do test for autocorrelation. So this one is the command for estimating and later one to step estimator. So look here, when I run, we have gotten a result. And in this, let's first see what this command means. So as usual, log of wage one is the dependent variable. These are the independent variable, and all these independent variable are strictly exogenous independent variable. So you know strictly exogeneity means none of these variable is related with the past, present, and future value of error term. So these variable are strictly exogenous variable. Lag 2 is defined as like earlier. Since we are using two lag value of dependent variable as a regressor, so this is option for that. Two step using two step basic robust. We are using robust standard error. Now come on to which one is the predetermined explanatory variable here. And next two are endogenous variable. So in a case of endogenous variable, we know explanatory variable is related with the error term. So since we are working with the panel data set, so here you can see MS is endogenous variable. So MSIT is correlated with the current year, or if T is the current year, so MS IT is related with the epsilon IT, which one is the current year error term. And because of that, this particular variable become endogenous. If you see this lag 0 2, so the first one 0 means the level values of ms variable is endogenous variable, and 2 we are assigning here for two instrument variable for this particular variable. Since endogeneity case you use instrument, they are defining a maximum lag length of this particular variable, which can be used as an instrument for this variable, because this one is endogenous variable. So in this particular case, two instruments are ms it minus 1, ms it minus 2. Similarly, in a union case, union is endogenous here. Label values of endogenous and current value of union is endogenous. That's why it is 0 here. And 2 is 2 lag value of union are used as a instrument for union variable. In a predetermined case, uh, you can see here, since WKS variable, which one is here weak worked, is not related with the current year error term. So if I let me use the next board. So if I open this, in a strictly exogenous case, we generally assume the expected value of xit and epsilon it equal to 0. This is what our assumption, and this one is for all t and s. In a predetermined variable case, we go with the assumption that expected value of xit epsilon is not equal to 0, and this one is for all s which one is less than t. This means we allow correlation between past error term with the current value of explanatory variable. But at the same time, when we write xit epsilon is very 0. So that means the current air value of explanatory variable is not related with the future value of error term. And when this condition satisfied, we can say xit1 is predetermined variable. So this one is called predetermined variable. So for that, if you have a look on variable, Which one is the weak work variable? Leg 1 means we are using first leg of weak work variable as a explanatory variable, and 2 means again we are using 2 leg up to 2 leg value of weak work variable as a instrument for weak work. So, so this and these are the explanations of using different options along with the different variables. And as I said, when we enter, we get the result. Interpretation of result is same as like before. Now look here, the student variable explanation. So student variable for log of wage are first and second leg value of log of wage, third leg value of log of wage, and fourth leg value of log of wage. So that's why it is 2 divided by 4 is written, because maximum 3 legs are used for estimating the estimates of parameter. Similarly, for lag value of weak work variable, there are 2 instruments. So the lag value of lagged weak variable, and again second lag value of lagged weak variable. For MS again there are 2 instruments because we restricted and Stata to use 2 instruments. So that one is second lag value of MS and third lag value of MS variable. And similarly we can uh, interpret for union variable. So total number of instrument is here 40. So if you read the textbook, then we come to know 11 are coming from log of wage variable instruments, and next and 8 and 8 are coming from these 3 variable. So 24 instruments are coming out from these 3 variable, predetermined and endogenous variable, and 5 are exogenous, strictly exogenous variable, which become instrument for itself. So total instruments become here 40. And how many parameter you are estimating? Only 11. So for estimating a 11 parameter, how many? 1, 2, 3, 4, 5, 9, 10 it is coming out. And 1, 7, 8, 9, 10, 11 coming out. Including constant, it is 11. So for 11, we are using 40 instruments. So these are the results. Now let's move on to the test. So first we do the test for autocorrelation, and for that, after running this regression equation, we just need to type E stat A bond, and this gives us result of autocorrelation diagnosis test. So the null hypothesis is here. There is zero autocorrelation in false difference form, So these are the order. So order 1, order 2, order 3, and we can see here we are at order 1 the null hypothesis is rejected, but at order 2 and order 3 null hypothesis is and order 2 and order 3 null hypothesis are not rejected, and that one is the condition. And if this results comes, that mean that here there is a no specification problem with our regression model. If contradict happens, that means if you reject and we accept first and reject later, then means there is some kind of specification problem with our model. So uh, a little bit more explanation is given in the book. You may go through that. The next one is, as I told you, that one is Sargent test, which test whether the model has used more than required instrument. And for that test, we need to run a regression model without robust standard error. So without robust standard error, if you run regression, and then after we need to put a command of Sargent test, which one is e stat Sargent. And null hypothesis of this command, there is no over identifying distinction. That means you haven't model haven't used uh, unnecessary or more than required instruments. So it is accepted here. The null hypothesis is accepted. That means whatever number of instruments have been used by the model is correct. So generally these two commands and as a test for uh, specification of the model we run, and if you get such a kind of result, that means you are moving in a right direction. And this much in this course. As I told you, even the Arduino bond estimator suffer with some or certain kind of drawbacks, and because of that reason, and in these days, people prefer to use system uh, bond estimator or system GMM estimator instead of Arduino bond estimator. So system GMM estimator is also more or less uh, gives us similar kind of result, and the way we use explanatory variable, endogenous variable, predetermined variable are almost same, with a little bit of difference where we specify every time we are using system GMM estimator or first difference estimator, because here it is implicitly assumed that we are working with the first difference estimator. There we need to specify the same in a different form. So, but more or less we'll get a similar kind of result. So this much for today. Any doubt?
Sir,
Hmm?
sir, our